continuing along, let's take a look at C. In C, we have negative 6x to the negative second. Again, notice that we have parentheses on this one, which does matter. It means the entire negative 6x, because it has a negative exponent, should drop down to the denominator of a fraction. The negative 6x is the base, will not change. It's only the exponent will go from being a negative 2 to a positive 2. And then because the entire piece moved down to the bottom, there is just our normal hidden 1 there. Now, remember, we still have to do the math here. Well, what's the math? We've got the 1 on top, and we have to actually do the multiplication with this negative 6x squared. Remember, negative 6x squared means I've got 2 of these, 2 negative 6x's multiplied together. Well, then let's go ahead and multiply that out. A negative 6 times a negative 6 is actually going to give us a positive 36. And then let's see, what else do we have? An x times an x. Well, that means we're going to count up our x's when we're multiplying. We've got 1 here and 1 here. We're going to add those up. 1 plus 1 is a total of 2. So we've got an x squared on the denominator. Or we talked about this a second ago. You can just square everything inside the parentheses, and squaring negative 6 does get you a positive 36. Squaring the x does get you an x squared. Either way, you get 1 over 36x squared. Last one, let's look at D. In D, we have negative 4x to the negative third. Notice we've again got a negative exponent on our x, only on the x because there is no parentheses, which means only that piece is going to move to the denominator. So when we move the x to the negative third to the denominator, the only thing that changes is that exponent goes from being negative to positive. So what's up on top then? Well, remember, we're not moving the negative 4 because it doesn't have a negative exponent. It's just a regular negative number. So we're going to leave the negative 4 where it is, up on top of the fraction. And that's it. We're done. That's our final answer. Let's do some more problems with negative exponents. Let's take a look at this next group. Let's look at problem A. In problem A, we have 4 to the negative 1 plus 6 to the negative 1. Well, let's deal with each of these negative exponents separately. So if we have 4 to the negative 1, it means that the 4 is going to drop to the bottom of a fraction. And again, just like before, the negative exponent, which was a negative 1, will become a positive 1. And what's hidden up on top when everything drops is just a hidden 1. Okay, now let's deal with that second fraction, or that second, negative exponent, and see what happens with it separately. Well, we have a negative exponent, so it will drop to the bottom of its own little fraction, 6 here, with the negative exponent will become positive when you drop it. And again, you'll have that hidden 1 because the entire piece dropped down to the bottom. And we were just supposed to add these two. Well, now this has turned into adding two fractions. Well, first of all, I have to simplify these two fractions by saying, well, 4 to the first power is just a regular 1 over 4. Plus, we've got 1 over, well, what do we have on the second fraction? We have 6 to the first power, which is just anything raised to the first power stays the same, just a 6. Well, for adding fractions, how do you add fractions? You have to get a common denominator of, well, 4 and 6. The best, smallest common denominator, LCD, that you can get is 12. So, how do I get the 4 to turn into a 12 first? Well, we'll multiply it by 3. But then you have to multiply the top by 3, which gets us a 1 times 3, which is 3. On our second fraction here, we want to get the 6 to turn into a 12 as well, so I can have a common denominator. That means I need to multiply the 6 by 2, but then I have to stay balanced. I have to do the same thing to the top. which gets us a 1 times 2 on top, which is just 2. Once you have a common denominator, then you can go ahead and add, and the denominator will stay the same. Adding the tops of the fractions, normally now that I have a common denominator, 3 plus 2 is now going to give us 5 over 12. Just like any other problems in math, if you have a fraction, you need to make sure it's reduced. Our 5 over 12 is reduced, so we're done. But if it had not been reduced, we'd need to reduce it. Continuing along, we've done these first couple groups of problems. And then we have done the first one on the second group. Let's take a look at B. In B, let's see, what do we have? We have 1 over 2 to the negative third. So this time we have a negative exponent that we want to deal with, but it's already on the denominator. So just like before, the only thing that moves is the thing that has the negative exponent. So the 1 is going to stay where it is. The 2 to the negative third with the negative exponent is going to move up to go with the 1. So it'll be 2 to the, remember when it moves, the only thing that changes is the negative exponent becomes a positive exponent. Okay, so what's next is remembering when you see two things side by side and you don't see an operation in the middle, that it's understood to be multiplication. So now what? Well, order of operations says that I have to do any kinds of exponents first, which means I need to do this 2 to the third first. Well, 2 to the third is going to be 2 times 2 times 2. Well, 2 times 2 is 4, times 1 more 2 is 8. Now, the one that was out in front just says multiply by 1. Well, 8 times 1 is just going to be 8. So that's our final answer, 8. So that was our problem for problem B. Moving along, let's take a look at C. On C, we've got 10 to the negative second and 2 to the negative fifth. Now we have two different negative exponents, but one's on top and one's on the bottom. So the negative exponent that's on the top, to make it positive, we're going to move it down to the bottom. And the one that's on the bottom, the 2 to the negative fifth, to make its exponent positive, we're going to move it to the top. So in a sense, this is just going to flip everything upside down because they both have negative exponents. So the negative exponent, the 10 to the negative second, moves down to the bottom and becomes 10 to the positive second. Remember, the base stays the same. The only thing that changes is the negative exponent becomes a positive exponent. Now the 2 to the negative fifth, again, the base will stay the same as 2, but the negative fifth, the exponent, becomes a positive 5. Now, I know it is very, very tempting to want to reduce the 2 and the 10, but you can't. Order of operations says you have to deal with any exponents first. So the only thing I can do right now is reduce the 2 to the fifth and figure out what that is. Well, remember, 2 to the fifth is 2 times 2 times 2 times 2 times 2, 5 2's. We can use our calculator. 2 times 2, though, is going to get us 4, times another 2 is 8, times another 2 is 16, times one last 2 is 32. On the bottom, we have a 10 squared, which is 10 times 10, which is 100. So we get 32 over 100. Now we are getting a fractional answer with no exponents now. So now I need to reduce, if I can. Both 32 and 100 are both divisible by 4, so let's reduce that out. And let's see what we end up with if we reduce it out by a factor of 4. And that will get us 8 over 25. It can't be reduced any further, and that would be our final answer that we would give for C.